Okay, now comes the data model. Well, you've all seen the albums table, right? Here you can see albums. Coming from SQL world, the most obvious thing that you would think of doing is, because I like the genre rock, I want to list all the albums with the genre rock. At the time, I didn't think of this, what is it called, table called albums by genre. I just said query album table. But it said, well, you cannot use the column genre to query this particular table. This is where the double-edged sword comes into play. It'll throw a nice ugly exception like this and said, get out of here. The only columns that you can actually use to query is the one that is over here, indicated by primary key. So if I do this, it says get out of here. But if I do this, which contains the title and the year, it gives me a result. And I've limited the result. No, because I use the title and year, so I don't have to limit the result. So if I use a primary key, it gives me a result. If I use any other column, it doesn't give me a result, which is exactly why you need all the other tables. Because without that, you can't get away. Yeah, I was trying to be a smart ass thinking, yeah, I will get away. I don't want to do replication. No, Cassandra won't allow you. Well, why can't I query with other columns? That's the first question, right? Why? Why not? Because you have to know exactly how Cassandra stores data internally. This is where the knowledge of internal storage structure becomes quite handy. Internally, Cassandra stores everything as map of maps. That is what column family is all about. It is not tables. Even though you see tables over there, internally it's not tables. You'll see how internally it is stored. So here's the physical storage. So this is the partition key. Well, obviously this is not albums table. This is a movie table which I created with some movies that I liked. So the partition key 1, 2, and 3. Think of it like a primary key column in a table. And here you see it as a partition key. So 1 contains the whole movie in there. So this is a map containing a key and a value, right? So that's the first level of map. Key and the whole thing, value, value, value. And the second level of map of maps, that's why I said it's a map of map, is because in there, in the value, you have another map. Key, value, key, value, key, value. So every time you deal with any database from column family, you're actually dealing with map of maps. You're not dealing with tables. But CQL gives you a tabular representation because they want SQL people coming from SQL world to adopt it and understand it easily. Yes?
This also means that you store a lot of more data in your database.
Yeah, precisely. That's true. But data is cheap. Memory is cheap. So, yeah. And that is why, well, the more data that they sell, the more storage you use, the more money they make. Yeah. And they say you don't have to do joins. Well, it comes with a price. You can't get it. There is no such thing as free meal, right? Unless, of course, you come for the meetup over here. Then you get a free meal. So the 3 rows that you see over here, so I'm going to translate from SQL world to SQL world so that you are familiar with the SQL terminology. So these 3 things are called partitions. They're not called rows anymore. Forget rows. It doesn't exist anymore. And that particular thing is called a partition key. Those are key value pairs. And this is exactly how, it's actually definition, but I'm not going to read that. So those things are called cells. What's a partition key? A column, The reason why it's called column family is because they are dealing with columns here. Column, column, column. That's why it's called the column family. And the other thing is that all the items that you see are actually sorted by columns. So every time you write data, you're writing multi-dimensional data which is sorted. The reason why you sort and write data is because when you read, you get performance gains. And you will see that very quickly when you start to write events in an event log, which is the use case that we are trying to use right now. Because if I'm writing events in an event log, I just want to look at some event. Imagine a fraud detection system, which is what we were looking at in one of the first screens. If I'm running a fraud detection system, I want to look for fraud in a particular time window. And then if the data is already sorted, I can get immediately the data because the data is sorted. I don't have to get that and sort it. It's sorted. So all that I have to do is get it, which is already sorted. You know, obviously there are limits. So the maximum number of columns per row, because there is also another important difference between Cassandra and a relational database. In the relational database, when you create something like a row, what happens is that the space is already pre-allocated for that particular row in that table. But in Cassandra, if you don't put some value for that particular column, no space is actually used. So if the column value is empty in the underlying physical storage, there is no usage of data. But they also say, hey, you can throw in as many data as you want, but that's just a story. You want to know what the actual limit is, right? So the actual limit is, this is the theoretical limit. They said you can have 2 billion columns per row, but in practice you can have up to only 100,000 columns, but I think nobody's going to go over 100,000 columns, so which is fine. And the maximum data that you can have in a column is 2 GB, but in theory it's about 100 MB. So yeah, you're going to have more than 100 MB in one column, probably time to refactor it. Yeah.
Questions. Let's say you're inserting a list of artists,
Mm-hmm.
like there.
Mm-hmm.
You already have John Lennon and the Beatles,
Mm-hmm.
and Paul McCartney comes along.
Mm-hmm.
Then Paul McCartney has to be sorted in the middle. But if it's already written to the SS tables, it has to be rewritten to.
That is where the merge and compaction comes into play. The merge, what it does, yes, it is true. Because the data is not completely sorted, it is sorted for the fragment that you write. So in that SS table, that one of the several SS tables, it is sorted. But then obviously during compaction, all those things are sorted and compacted. And then when you do a merge, where you take data from 2 or 3 SS tables and also the mem table and then give the value, again a sort takes place. So yes, they do like that, but not completely. So there is some level of sorting in there. So it's like, think of, it is easier to merge like a binary sort, you know. If something is already sorted, it is easier to merge something that is already sorted than to sort everything that is completely unsorted. It just gives performance gains. Yes, for that you will need something called clustering column. I'm going to get to that in a minute. Yeah. So these are just the concepts right over here. This is the SQL view, which means if you use the CQL shell, this is how you will see data, and this is how the data is stored under the hood. And as you can see, some of them have no data, and here there is no usage of space. Just keep that in your mind. So now then you will go back and understand why things are done. And actually there is a tool called Cassandra CLI, which is command line interface, which is the old tool. Now they deprecated it. So if you start to use it, they will say, this tool is deprecated because, yeah, and it will be removed in Cassandra 3 because it was using the thrift protocol. There you will actually see that it is just a name value pair. But in the new Cassandra 2, you see tables. So that's why you're getting misguided. Okay. This is a very interesting topic. Upsets. There's also a very funny saying called, when you do an upset, you will be upset. The reason why it is called an upset, because in Cassandra, there is no differentiation between an update and an insert. Update and insert are the same thing because we are doing only write, right? So they took the update, insert, upset. Okay. What happens is that Cassandra does not perform a read before a write. Very important. Which the reason why they did what they did is because imagine a cluster with billions of, like, let's take Apple's iCloud cluster with 74,000 nodes. Are you actually going to go and read data in 74,000 nodes before you actually do a write? What is going to happen to your performance? It is going to suck. So they say, we're not going to do read before write. We just close our eyes and write data. So that comes obviously with a cost, because if you do write before read, you're going to have upset problems, which will upset you very soon. So that's an optimization by design. It's not a bug, so you cannot report a bug. And we're going to see why. Classic example, users table, something I created just for this demo. You have no, well, right now we have no users, so we have only a very simple data model. Primary key is the email address, and then the password and the user ID, blah, 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 whatever. And then what happens is that when I write this particular insert statement, the first one, it just succeeds because there is no data in the database, just as you expect. The second one, though, is, let's say another user comes in and then he wants to use the same email address. It doesn't check, hey, is there already a record in the database with a primary key as test@example.com? There is no such thing as primary constraint violation. So what it will do is, example, let's just take an example. My friend York over here has created york@google.com or whatever, right? And then I don't really like York. So what I'm going to do is I'm going to use the same email address of York and then override his password so that I can block his account. And I can, if some idiot went and wrote this kind of Cassandra query, what then I can do is I can use the same email address of York just by knowing, hey, that is his email address he used in Facebook, overwrite his password, and I take control of his account and I can do whatever I want. York will probably find out later on, but before that, damage has already been done. Okay? But that is the kind of thing that can happen in Cassandra, which is why you as developers should explicitly perform a read before write. The database will not do it for you. You do it yourself. Second case where upsets will make you upset. Well, you can actually do an update because there is no distinction between update and insert, right? If you write an update statement for an entry that does not exist, Cassandra will say, okay, I'll write it in because there is no distinction between update and insert. But in a normal database, what you will expect is that if you do an update to some record in a table that doesn't exist, the database will say, get out of here, there is no such row, right? Cassandra says, okay, and then it goes ahead. That's the second case.